Hi, and welcome back. In our last lecture, we pre-processed several discrete variables for the PD model. Here we will look into more advanced ones. How about the state of the borrower? This information is contained in the address_state variable. There are dozens of states, so you can imagine how this task will be much more challenging. Again, let's start with running the woe discrete function. Let df_temp equal woe, discrete from the df inputs pre-processing data frame, the address_state independent variable, and the df inputs pre-processing data frame. Here's the results table with the weight of evidence and other useful statistics. Naturally, the ADDR state variable has many categories, 51 to be precise, 50 for all states, and 1 for the District of Columbia, abbreviated DC. It will be difficult to decide how to group the different states without plotting the results. So let's run our plotting function. We run it from the dftemp data frame again, because now the dftemp data frame contains the results from the ADDR state variable. Note that there are only 50 categories appearing in the results table. This is likely because there are no borrowers from one of the states. By the way, the missing state is North Dakota, abbreviated ND. Let's keep that in mind and make sure we add this state to a category later, just in case there are some borrowers from around there in the future. To do that, let's make sure there will be a dummy variable for North Dakota. So, if there is such a dummy variable already, we don't do anything. Else, if there isn't, we'll create it and set all its values to 0, because in this case, there aren't any borrowers coming from North Dakota. Now, we can see here that there are 2 states, Nebraska and Iowa, with a considerably lower weight of evidence compared to most states. There are also 2 states with a considerably higher weight of evidence, Maine and Idaho. Note that weight of evidence for the last state could not be calculated because there are no bad borrowers. The other 46 categories appear to have very similar weight of evidence values compared to these 3. Looking back at the results table, we can see that the first 2 and the last 2 states actually have very few observations. It doesn't make sense to leave them in separate categories. Besides, it is highly likely that the low number of observations is the reason for their extreme weight of evidence values. So we'll include these states in the first, the worst, and the last, the best category respectively. Now let's focus on the other 46 states. We can do that by running our plotting function on the results data frame again, taking all rows except for the first 2 and the last 2. So plot by woe from dftemp I lock, rows 2 to -2, and all columns. This new graph gives us a different perspective. As Nebraska and Iowa were so far away from the rest of the observations, the initial chart was causing us to believe that all states are more or less the same in terms of weight of evidence. Now we can clearly see that there are some differences. We can see over here that the first state on the graph has considerably lower weight of evidence than the next one, and that the next 3 states have similar weights of evidence that are considerably lower than the weights of evidence of the following states. Therefore, it may make sense to keep the first state, Nevada, in a separate category, and the next 3 states in another category. However, we can see from the results table that Nevada also has a very low number of observations, or borrowers. From the following 3 states, Florida has a number of observations that make it suitable for both keeping it in a separate category or putting it in one category with other states. Therefore, let's combine Nevada with the following 3 states. Let's also remember to put the first 2 states we left out from the last graph, Nebraska and Iowa, in this first category. In such cases, it is useful to use pen and paper or to write comments in your workbook, as there are many different categories. Keep in mind the only state we had no information about in the results table, North Dakota. Since this first category includes the states with the highest credit risk borrowers, it makes sense to include a state we have no information about here too. This reflects our conservative risk management attitude. By default, as risk managers, when we have no information, we should assume the worst or highest risk. With this note, Our first dummy will include the first 6 states from our results table, from Nebraska to Alabama, plus North Dakota. Okay. Similarly, the last 4 states displayed on the last chart can be grouped together in one category based on their rather low number of observations. Also, don't forget to include the 2 states we didn't display on that end of the scale on the last chart, Maine and Idaho. So, our last category will include the last 6 states from the results table, from West Virginia to Idaho. Now, let's take a look at the remaining 38 states. To get a better perspective, let's plot only the remaining states, so from rows 6 to -6. The result you see here is more or less what we expect from a typical weight of evidence plot. Let's try to create the categories. Starting from the states with the lowest weight of evidence on this last graph, all states from New Mexico, NM, to California, CA, have similar weight of evidence values. But we also need to take into account the number of borrowers. 2 of the states stand out with a particularly high number of borrowers, New York and California. There are indeed plenty of borrowers from California, perhaps more than from any other state. So California definitely has to be in a separate dummy variable by itself. I also reckon New York should be in a separate category as well. That means the rest of the states can either be all in one group or in several groups, depending on the increase in weight of evidence and separated by New York and California. We'll opt for the latter option and put them in separate groups. So New Mexico and Virginia will be in one group. New York follows. Next, the states from Oklahoma, OK, to North Carolina, NC, will be in another group. And then there's California. What is important to realize in this methodology is that it would not be correct to combine New Mexico, Virginia, Oklahoma, and North Carolina together because they are separated by New York on the graph. The reason is not the graph itself, but the fact that nearly 10% of our observations are from New York, thus kind of breaking the link between Virginia and Oklahoma. All right. Next, we can see that all the states from Utah to New Jersey have similar weights of evidence. Therefore, it's suitable to represent them with one dummy variable. Remember to check the number of borrowers, though. None of them stands out with a particularly high number of borrowers, so we'll put them all together in one group. Then the states from Arkansas to Minnesota have similar weights of evidence and are not particularly big on borrowers. Let's create one dummy variable for all of them. We'll do the same for the 5 states from Rhode Island to Indiana. And then the same for the 3 states from Georgia to Oregon. The following states, Wisconsin, WI, and Montana, MT, are a bit apart in weight of evidence, but have a rather low number of observations, so we can put them in one group. Next, there are Texas, Illinois, and Connecticut, which all have similar weight of evidence values. But notice the number of observations. Texas alone has a very high number of observations, perhaps the 3rd higher after California and New York. Therefore, we are compelled to leave Texas in a separate category, and the 2 following states, Illinois and Connecticut, together in another category. The weight of evidence of all 6 states after that, from Kansas, KS, to Mississippi, MS, is considerably higher than the weight of evidence of Connecticut. At the same time, the number of observations per state is very low for all these states. This makes the weight of evidence somehow less reliable, even though indicative enough that borrowers from these states will most likely be better than borrowers from other states. Therefore, let's group all these states together into our final dummy variable. Great! What's left is to create the actual dummy variables and leave assigned one of them as a reference category in the regression model. Again, this is going to be the variable with the lowest weight of evidence. For the categories representing the state of the borrowers we have determined, this is the category of the states Iowa, Nevada, Hawaii, Idaho, Alabama, and Florida. All right. Let's create these categories in our DF Inputs Preprocessing data frame. Remember, we already have dummy variables for all single states. So for the categories with only one state, we can use these dummy variables and we don't have to create new ones. For the categories with 2 or more states, we can use an approach similar to the one we use for the categories of home ownership. Namely, we will sum the dummy variables for every state that is part of a bigger category, and this will result in a dummy variable for the whole category. For example, df inputs preprocessed, address, state, colon, and here we itemize the states that comprise the category, separated by underscores. So, let this new variable equal sum of df inputs preprocessing, address, state, colon, the first state, then the same for the second state, and so on. Writing similar expressions for all the other categories with more than one state gets the job done. Now, let's add these variables to the list with dummy variables, and let's add the dummy variable with the states from North Dakota to Alabama to the list with reference categories. And that was it. We're done with the state variable, probably the hardest one to preprocess in this dataset. Good job! After this lecture, we have prepared some homework for you to practice your newly acquired preprocessing knowledge. Good luck, and thanks for watching.